Hello, and good afternoon. I think as we're getting started here, we are sounding good. It's very loud, sorry. So battery engineering and manufacturing is still a very new area for many companies and many manufacturers around the globe. And today, what we're going to talk about is how Siemens and AWS are partnering to help some of these companies solve some of these most pressing challenges for battery manufacturing. I'm Dale Tudd. I'm the Vice President of Industry Strategy at Siemens Digital Industry Software. And today I'm going to be joined by Maria Reuter from AWS. Maria is the Principal Partner Development Manager, and she's leading the collaboration with Siemens in this battery space. With the increasing demand for electric vehicles, for hybrid electrics, one of the things that's come along with that has been a massively increasing demand for battery production. And so we've seen like 30% increase year over year of battery manufacturing. And we're seeing a lot of investment in new gigafactories around the world, $300 billion of investment just in gigafactories. And so as companies are trying to ramp up their battery production to match the demand that they're anticipating in 2030, there's just really a lot of requirements to have new solutions to be able to stand up these plants faster. You can imagine how long it takes to stand up a new production facility like this. It might take 3 to 5 years from the time you decide to do this. And so there's a lot of opportunities to really try to go faster. So as the companies look at how do they stand up new factory capacity, how do they scale it up fast enough to meet the demand? The demand right now is they're able to keep up with it, but as they look at the demand of electric vehicles continuing to increase, they expect that the battery demand is also going to go up. They're struggling with getting more energy density, so some of the engineering problems, how do you get more energy density so that you can either reduce the weight of the batteries or so you can increase the range of the cars? One of the challenges once they get into manufacturing is scrap rate. They have in some cases we're hearing about 30 to 40% scrap rate of the battery material as they're producing it, and the quality issues that they're struggling with. So they're trying to figure out how to go faster and produce higher quality batteries as they go. And then finally, one of the things that we see a lot of companies that are also struggling with is getting enough talent to work on batteries, to manufacture batteries, to design batteries. We have a lot of engineers that used to design internal combustion engines and mechanical drivetrains, and now they're switching over to electric engines or electric motors as well as the batteries. And so really trying to figure out how to address the talent is a big challenge for companies as well. So these are some of the things that we're going to talk about today as we go through this section. So one of the challenges is that battery manufacturing really requires a lot of collaboration across a lot of different domains: electrical, mechanical, software, electronics. And so the traditional methods for engineering also need to be updated to match the requirements for battery production. So Siemens Accelerator is ideally suited to help solve some of these problems. We're able to provide, I should say, one of the things that we really try to bring together is the real and the digital world. So we want a virtual representation of the product, the manufacturing processes, all aspects of the battery system. We want to be able to represent that digitally so that we can emulate or simulate what's going to happen in the real world, actually predict what's going to happen in the real world. We do this with connected end-to-end solutions. We use a comprehensive digital twin to be able to actually understand how the battery system is going to work. And I'm calling it a system because it truly is a system. There's a lot of components within the battery. It's in a box. There's electronics. It comes together in order to provide the power. And so the comprehensive digital twin, you're able to use this to predict outcomes as you're developing a new battery solution, as you're developing a new manufacturing process. We'll talk about some of that today. But because we're also connecting it together with digital threads, you're able to start to automate some of these workflows so you have a seamless transition from one solution to the next. As you go from engineering to manufacturing, you want to be able to connect those processes together. And there's a lot of data involved and using data analytics and AI to help manage this process. Another very important part of this system are our solutions is really this ecosystem of partners that we're creating. One company can't do it alone. And so this is, for example, why we partner with AWS in order to be able to provide cloud-based solutions with our digital, with our digital twin and be able to provide that foundation. And Marie's going to talk about a lot of that as she goes through her part of the presentation, why it's so important to be able to work with a lot of different partners in this open ecosystem. So why Siemens and AWS? Well, with Siemens, we're bringing together the top supplier in the world for digital solutions, for industrial solutions. We're leaders in IoT and PLM and manufacturing and really in digital twin solutions. And we're partnering with AWS, which is #1 in cloud-based solutions. So by bringing together these solutions, we're able to provide these solutions in the cloud. Makes it easier for companies to scale up. Companies of any size can adopt it. It's easy to manage. And then they're able to deploy it faster, and they're able to get value. That's that time to value. They're able to get value out of their digital solutions faster by being through this partnership that Siemens and AWS have. So with that, I think I will turn it over to Maria. Thank you, Maria.
Thank you, Dale. So Dale talked about the different challenges that battery manufacturing has. One of them is the challenge how to scale up, how to accelerate the battery design and move from the single factory to the gigafactory. And there are different ways how you can accelerate this. And I would like to talk about 3 of them so that we dive deeper a little bit in each of these areas. So the first one is about the simulation. How can you improve and accelerate the simulation process of your battery? You can use the Siemens Sim Center on AWS High Performance Compute to run the simultaneous simulations and run it on the high performance compute instances and GPU. In addition, you can embed the machine learning models into the simulation process, so you have the information much earlier in the simulation, this historical data, and improve your outcome at the end of the day. The second one is about the collaboration between the different disciplines that are involved in the battery design process. With the Siemens Team Center on AWS, the product lifecycle management collaboration platform, you can create the single source of truth on one side, but you can also use the generative AI assistant, which allows you to kickstart the design and configuration of the battery with natural language. So you don't need to be an expert in the battery manufacturing and a specific large language model to find the right information, the step-by-step guidance. This can be provided to you. And another benefit that your teams get, if you have teams working on the chemical design, on the mechanical design on the battery, on the production of the battery, you can establish the closed loop of the information between these different teams much quicker and force it with the natural language. And the third one is about the building the new application yourself if you want to improve your production process. For this, we launched just beginning of the year, together with Siemens, with Mendix, the Bedrock connector into Mendix. So that means that you have an access to the multiple large language models that are based for the use of your specific issue to select the right model you need. And you don't need the specific knowledge about the application, the software development, and you can use the low-code platform Mendix in combination. In this way, your teams can innovate much faster, both on the creating the new application and then also using the large language models for this. For all of these solutions, you need the foundation. Data foundation for this, which can help to interconnect the different systems, tool chains, and disciplines with each other. And it's not only in theory, and some customers are already doing this. For example, Northvolt, who was already using the Siemens product lifecycle management to use the single source of truth and improve their efficiency by 20% in their operations, but also contributing to the reusage, recycling of the battery materials by 50%. And the foundation for this, again, was the cloud factory fabric that was a modular design so that they can scale the factory, plug in, plug out some modules of the factory in a very flexible manner. So that was the scale challenge, but the big issue that Dale was talking about is still the quality issue, the quality of the battery, this high scrap rate. So how we can help with this? And the answer to this is the OT and IT integration, so combining the data from the operational technologies and informational technology. So what you can do on the one side, you can create this seamless closed loop between the assets on your shop floor and the cloud. And if you want to learn more about this, we have a session today at the Siemens booth at 2:30 p.m. So please come there and we will talk about, our colleagues will talk about this, how exactly that helps to accelerate this edge-to-cloud integration. And another example is the executable digital twin of the battery. What you do with this, you combine the real product, the real process with the digital one. For example, the foil breaks and this prevents the production, it causes downtime, and usually there is a hardware sensors used to measure the vapor tension. What you can do now, you can additionally put the simulated sensor, which can calculate the vapor tension, and in this way, you can prevent the foil breakage. The customers was using this already and saved on the prevention of the downtime. So we talked about now about these two examples, but there are much more innovation and acceleration happening on the OT and IT integration on the factory level. This is when we talk about manufacturing operation management system. And we have also a session today. You actually need to run after the session. It's 1:50 p.m. So where our colleagues will talk about the Siemens Ops Center on AWS Cloud and on premises, which allows Toyota, and they will be on stage as well, to accelerate their operations, increase efficiency, and also be more agile. So this is examples of how you can deal with the scrap rate, but also you can do with the scale-up challenge. Another problem that we still have to solve is the team and talent scarcity. So Dale, how we can deal with this?
All right. So, as we start thinking about, we have a lot of new people. We need to develop the skill sets. Well, one of the things that we can do to help accelerate their learning curve is to be able to present information to them in a way that they can consume it easier. And so we're doing that. One method is through the industrial metaverse. So what we have here is with the industrial metaverse, it's not just a 3D simulation. We have an example here from Fryer. So we're able to bring together data from all different sources, 3D CAD, geometry, and information that's being used. So here we zoom into the plant itself. We're able to come in now, do a fly through the plant, and we come to this mixing machine. And so this mixing machine, we can see the 3D geometry. But more important, we can also start to see operational data. So before you have the machine, you're able to predict how it's going to work. Once you have the machine, you're able to compare that data back to the digital twin and actually see how it's working. And now you start to see, maybe you see a problem. So you want to understand that problem. You're able to look at the simulation, how it's mixing together. Is it mixing like you expected? You go back and you compare it to data. Another example of this is this robot. And again, you have a digital twin, you have real world information, you're able to bring those together. And the information is synchronized. And as you want to start to understand how the system operates, now you can do a deep dive down into the CAD models and the CAD geometry. So again, this is all the information together that defines the plant with the operational data that actually helps them run the plant. In this case, now you're starting to look at energy usage throughout the plant, something you want to optimize to minimize cost and improve sustainability. So finally, we fly into the manufacturing area. And as you're starting to develop a plant and a new factory line, you want to simulate it. You want to know up front that it's going to work before you start investing tens or hundreds of millions of dollars in this new plant. So you're able to go through and simulate every aspect of your manufacturing facility and make decisions based on how that is working, and whether or not, and make decisions based on what you're seeing in real world data, or in this case it's simulated data. So then as you go through and you have the real plant up and running, you can again compare it back to that operational, that digital twin, and you can optimize your plant using that information, that real world data. So this is just an example of how the industrial metaverse, it's more than visualization of CAD systems, but it's being able to bring together all aspects of how that plant's going to run. The mechanical data, the simulations, whether it's the simulation of individual machines or the entire plant, and then being able to bring the operational data in to make comparisons and judgments based on that. So as we wrap up, we really just want to talk about the value that Siemens and AWS is bringing to help companies solve these pressing challenges for battery production, and how closely you can be able to sync up the real world with the digital world and actually use the digital world to make decisions and to make optimizations of how your plants are operating. So we're able to bring our services, our domain knowledge, all of our software to our customers, but being able to bring it on a good data foundation and AI, as Maria was talking about, and be able to move faster with much more scalable solutions. So as I turn it over to Maria for her to wrap it up, I'm just going to say thank you for your time today. We appreciate it.
Thank you, Dale. Yeah, just to give you some more insights where you can find more information and also see some demonstration. So the first, of course, you can visit the AWS booth and learn more what we have to offer together with Siemens. There is a booth over there. And on the Siemens booth, which is in Hall 9 over there, you have the complete showcase of the battery manufacturing, starting from product design and engineering through manufacturing and also recycling. So you can visit it there, see it's live, how it works, and dive deeper into this real case examples. So I also want to thank you, Dale, for the great collaboration. Thank you for your attention, and have a good week at Hannover.
Thank you.
Thank you.